Let's look at two examples of finding limits involving infinity. So find the limit if it exists. We're trying to find the limit as x approaches negative infinity of this function. Now, what does that mean? So x gets really, really small. What will this become? Also, graphically, we're looking at this rational function's left end behavior. To the left end of the graph, is this function approaching any specific y value? But let's use that one strategy that we learned about last unit. Divide every single term. Divide all terms by, we have to find which term has the biggest exponent in the bottom of the fraction. This one's simple. In the denominator, there is x to the first power. X to the first power is the biggest exponent, or the term with the biggest exponent in the denominator. That's the one with the degree. So I need to divide everything by x to the first power, okay? All right, so divide all terms by the degree of the denominator, not the numerator, but the denominator, okay? So what will that become? I still need to write this limit notation down, but what used to be 4x squared is now 4x squared divided by x, plus x divided by x. Everything just get divided by x. And now the next line will be just us simplifying this. 4x squared divided by x is 4x, and we have plus 1, and x divided by x is 1, but 9 divided by x is 9 over x. Well, everything worked out okay except for this top one. Because, I mean, if we now separate all these, what will happen to this one? This will turn into 0, right? Because look, 9 divided by a really, like, all right, imagine this. 9 divided by negative 1 billion. That's a 0, right? So remember the property, limit as x approaches either positive or negative infinity of k over x, k can be any number, is 0. Using that, we know this is 0. But there is this other troublemaker right here. Let me box this. That will not be 0. That will be negative 4 times negative infinity. 4 times negative 5 billion. Negative 4 billion. It's going to be 4 times a really, really, really big negative number. So because of that, the limit will just be negative infinity. Okay? It did really good. I mean, I like that this was 1, this was 1, this was 0, but 4 times x on top of the fraction, that's just gonna be 4 times negative infinity. So it doesn't really simplify any further. What we got algebraically is that if I graph this function, left end will be pointing down. All right, let's test that. Okay, I'm going to graph this to see if that is true. If I graph 4x squared, if I graph 4x squared plus x divided by x plus 9, now let's take a look and see what x is doing to the left side, okay? See, I was worried for a second. I'm like, oh no, why is it going up? Look at this. When x is negative 1,532, look at that y value. Negative 6,000, 6163, blah, blah, right? So, I wonder if I can give you a good zoom, because if somebody looks at just that, they may say something like, oh, left end is pointing up, but that's not the whole graph. So if I zoom out a little bit, I will see the entire graph. and the other half of the graph is right there. So how about I adjust the x-axis a little bit for you, okay? Give me 1 second. What if I adjust the x-axis to negative 1000 to positive 1000, and then the y values to something like negative 2000 and positive 2000. It's not that good, but you see the graph right here. We have this shape of the graph going to the right side, this other half going to the left, and as you go to the left end, the graph is pointing down. So graph matches what we found algebraically. So the answer is negative infinity. Let me do one more. All right, I think the same thing will probably happen here. So what do we have to divide everything by? We need to divide all terms by x squared, because that's the term with the biggest exponent in the bottom of the fraction. So if I set up my work, I'll say everything is getting divided by x squared. See, everything got divided by x squared. Okay, now we need to simplify this. The top of the fraction, we have negative 9x. And then this one will be plus 5 over x. 8 minus 6 over x minus 8 over x squared. Now, let me tell you, these are the good ones. These are the good ones. These highlighted ones have a number on top and x in the bottom. These green ones will be 0. They will give you 0. But we have a problem. We have a problem. This troublemaker up there. That is negative 9 times x. So if you do negative 9 times 5,000, well, because you're going to have to plug in this infinity there, right? That's going to come out to be negative infinity again, because negative 9 times a really big number is a really, really big negative number. So, and then I guess that kind of happens when the numerator is bigger. We say the horizontal asymptote does not exist because the graph just goes up to positive infinity. But these two cases that we looked at, both of them are going down to negative infinity. So that's how you would do limits involving infinity.